Awesome. Well, let's kick things off. Thank you, everyone, for coming. I'm really excited to be here. Thank you for taking time out of your day to join this talk. I'm really excited to talk to you a little bit about what we're doing here at Vultr. Yeah, let's dive in. So my name is Nathan Goulding. I'm the Senior Vice President of Engineering at Vultr. And before we start, could I ask for a quick show of hands? Who here has heard of Vultr? I know you guys. Okay, so a few folks familiar with Vultr. So for those of you who are not, maybe I'll just spend a few minutes talking a little bit about Vultr. So Vultr is the world's largest independently held cloud computing company. We've been in business as the brand Vultr for 10 years, as an operating company for about 22 years. So we have a rich operating history deploying cloud infrastructure, and we do this in 32 data centers around the world. So we have a pretty good footprint, and we've been doing it for a long time. What this means, practically speaking, for end users is that we're able to address about 90% of the world's population in under 40 milliseconds. And this is really important for typical like web applications, content delivery, things like that. But it's also increasingly important for with the advent and explosive growth of large language models and generative AI, being able to serve up responses to users in country is important, both from a latency perspective, but also from a data and governance perspective as well. Like I said, we've been doing this for a long time, and excited to talk a little bit about what the architecture that we're working on here at Vultr for the future looks like. So there's been a couple of phases. I guess maybe another quick show of hands. Maybe if you've been working with cloud infrastructure for over 1 year, raise your hand. Okay, over 5 years? Okay, over 10 years? All right, 20? Any 20? No, okay. If you are familiar with the evolution of cloud over the years, there has been major waves that have happened. And from the early advent of cloud and cloud infrastructure to a cloud-native deployment and what that means, microservices, immutable infrastructure as code, and some of those best practices and how we can actually take those and apply those to AI-native applications and what that looks like. And obviously, we're here at Cephalacon, so a lot of that involves storage and the importance of having storage close to your AI application, and I can talk maybe a little bit about what we've been doing here at Vultr with Ceph to enable AI native applications and what the architecture of that looks like. So what you'll see here is a kind of a very generic diagram of what and it kind of ties together a little bit about the point of taking some of the best practices of cloud-native applications and how those can apply to AI-native applications in terms of best practices and principles. And so what you have on the bottom is what you would kind of consider to be cloud maybe 1.0 architecture of how you deploy your application into the cloud. And so you have your registries, both public and private, and that stores an immutable copy of your application that then goes through your CI/CD pipeline, where then it gets deployed into a region where you actually want to serve up your application to your end user. And so taking that principle and then applying that to an AI native application where you would have your model, which is an immutable copy of the trained model that you then would also go through fine-tuning, parameter-efficient fine-tuning, and then ultimately deploy that into the region where you're at, allows that to be served up to the user, again, in that region, in that location for latency and data governance reasons. So, and I should also say at Vultr, this is something that is not kind of like theoretical, this is practical. And so the entry point for consuming cloud infrastructure at Vultr can be either at the bare metal level, at the virtual machine level, at the Kubernetes level or at the higher level services, so like inference API or container runtime. And that really also kind of dictates how you architect your application for consuming the infrastructure that you're going to be deploying onto as well. And that also, I should say, with respect to our storage, all of those entry points, whether that's bare metal or virtual machines or container runtime or serverless endpoints or inference APIs, all of that can address storage in that's adjacent to where your application's running, and that's critically important for the performance, both in terms of inferencing as well as in terms of training. And this is something that we've done very recently. We actually, within the last month or so, announced a partnership with AMD where we're deploying their MI300X GPUs in a cluster and the storage that's adjacent to that. The performance characteristics of that are pretty incredible, and I can talk a little bit about what that looks like. So extending this a little bit more, so obviously, like from a generic perspective, two pipelines look very similar. You take your immutable application or model, you run that through your CI/CD pipeline, and then deploy that into the region. That also then can extend into your enterprise data sets. So if you have your whether that be customer data or training data or whatever the case may be, you have these enterprise data stores that you need to hook up to that as well, and pushing that through the same pipeline that you use for your application, your container, or your model, and then that gets deployed into the region. And again, from the region to the end user, expanding out what that looks like, you have, again, in each of these regions where you have it, that can then be used with Terraform templates to define the resources. And so you'll see, like I mentioned, like the entry point for what the infrastructure is that you're consuming, can be bare metal, it can be virtual machines, it can be Kubernetes. We also offer a wide range of both CPU and GPU manufacturer diversity. And so we like to, I guess we're in Switzerland, so we like to say that we're Switzerland when it comes to technology, or we're neutral. We work with a lot of different technology vendors. So that is, could be Intel or AMD on the CPU side, as well as NVIDIA and AMD and others on the GPU side as well. So that then gets, so again, kind of that's the middle layer there, and then moving that one over into declaring these into pods, and then having those be pushed out to the edge allows an end user in the region to hit the endpoint. And again, that could be an instance, a dedicated instance, or it could be a container endpoint, a container runtime or serverless endpoint, and the user is going to access that and get that response in the location that they happen to be at. Which is, again, super important. We see this all the time with our customers. That's also important and informs our storage deployment strategy as well. Data governance is obviously an incredibly important topic, and making sure that we're able to have storage from a compliance perspective that's in region, and then also making sure that that storage is hooked through high-speed networking to the application as well is incredibly important. So I'm really also excited. I think today is the day that we're announcing Vultr file systems. So we have, in terms of the storage offerings that you get through Vultr, there is object storage, which is S3 compatible API. So putting objects into buckets. There's also flexible block, which can be used for archival storage through HDD, but we also expose kind of mid-tier SSD and high-performance NVMe, as well as, and all of those get exposed as block storage that are resizable volumes. And then I'm super excited to release and announce that we have a file system support, which is a read-write-many file system that can be attached to multiple instances at the same time. And this is really, really important. And I guess I should say, maybe it goes without saying, but I should say it's all driven through Ceph. So we do leverage Ceph under the hood for all of our first-party storage solutions. And we have I guess, Bob, do we have the number on, do we have the vanity metric on that yet? Okay, somewhere north of 60 petabytes of self-storage deployed globally today. Like most vanity metrics, that can either be large or small depending on where you're coming from, but that we do that, and we have done that at scale for quite some time. And so again, Vultr file systems is super important also specifically for AI workloads, because we are driving use cases that are require the need for access to the data to be present in on multiple systems at the same time. And this is really, really important for AI applications specifically. And obviously, like a file system-based storage is important because you can attach it to multiple instances and access the same data. And we're doing that through VirtIOFS, which gets exposed to the instances themselves. But that's really super important because when you're doing training or inferencing, you have to have access, the application has to have access to the data itself, and it has to be done in real time. So this does enable for a lot of things for developer teams, IT teams, machine learning engineers, AI architects. Kind of enables a lot of this comprehensive AI computing and ensures kind of optimal resource utilization for accessing the data. So this is, again, really, really important. I should also say that the way that we're doing this at Vultr is through when we have our, and maybe I'll just want to be sensitive to time here. If we look at what kind of the overall architecture of a an AI native application would look like, you'll see in the middle here the actual, we've got both AMD and NVIDIA GPUs here, and those are accessing over high-speed networking. So in the case of NVIDIA, I guess maybe quick show of hands, who's familiar with either InfiniBand or Rocky networking? Show of hands. Okay, awesome, that's great. So in the case of NVIDIA, we deploy InfiniBand networking that allows each system to access the data over the high-speed interconnect. That can be done in a variety of different ways, and we support, again, over InfiniBand for distributed training and distributed inferencing. That obviously happens over the InfiniBand, but we also do in-band networking for storage access as well. And that happens both with AMD, which is kind of open standards based, which we're hugely supportive of, which is Rocky, and then with NVIDIA, we do it with InfiniBand. So that enables, and what we've been looking at, again, like I mentioned, we just announced the AMD MI300X cluster that we're turning online. We're looking at, for the storage system deploying there, that the requirements that we're seeing come in at, so each system itself, it's the OAM module, which is 8 MI300X GPUs in each system. And so if you have 400 gig front-end network for the system, you're looking at 50 gigabytes a second per GPU, which is the requirements for some of these training and inferencing applications, which is something that has, for us, is an exciting time for us. This is kind of new requirements that come in from our customers all the time, and it's been really exciting to work through the implementation of that and do that with an open standards-based solution in Rocky, and obviously that's all powered by Ceph storage as well. So that is kind of an overall architecture. I do want to leave a few minutes here for questions, and we have our storage team from Vultr here, which I'm really excited about. So, what's that? Half of the storage team, yes. Right, exactly. Someone's manning the ship. Anyway, I'll take a pause there. Any questions that we have that the audience might have that I can help to answer? Kevin, any questions?
I think Vultr file system available.
It's available now. Okay, well, if there's no other questions, again, thank you for coming. If you are interested, please go to vultr.com, sign up for a free account. You can actually deploy Vultr file systems or block or object, and you'll be able to access our object storage solutions without having to spin everything up yourselves. We've done all of that hard work, and we put all this stuff around the world. And so thank you for coming, and I'll be here, and the team's here as well, so I'm excited to meet hopefully a few of you around the conference here. So thank you.